PGY2310 cellular fluids. So first talk about body fluids and we talk about the compartments. Now body fluids, as we're saying, body fluids is just a fluid found in the body. Fluid in the body. You know that your body is, the majority of your body is made up of water, right? So that water can either be found inside the cells or outside the cells. Outside the cells is going to be known as extracellular fluid, IECF. Inside the cells is known as intracellular fluid, ICF. So imagine you have got, here is the first cell in your body, and then here is the second cell in your body. The fluid that you are going to find in the cell, now you know that a cell, we'll talk about this, cells are made up of the cytoplasm, okay, and just a membrane. The cytoplasm is going to be made up of two components. It's going to have the cytosol and organelles. Cytosol is just the fluid part. So that is what we call ICF, the cytosol or intracellular fluid. Now, the fluid that you are going to find between cells, that is what we call interstitial fluid, okay, or extracellular fluid. Now, also, blood vessels are not in the cells. Blood vessels are outside the cells. So the fluid that you are going to find in blood vessels, that is known as plasma, that liquid part of blood, it is also out of the cells. You also have what we call transcellular fluid. Now, transcellular fluid is a fluid that is found on special places in the body. For example, on your joints, you're going to find transcellular fluid. In the eyes, you have got a fluid there. They are the vitreous humor. Those are transcellular fluids. Transcellular fluid is actually a component of interstitial fluid, but found in some special cavities in the body. Okay, so Inter- ICF fluid inside the cells, ECF outside the cells. ECF can be divided into interstitium, transcellular, and plasma, three components. Okay. So this is what you're talking about. For example, in your abdomen is where you find these organs, the stomach, intestines, and these other structures. You can see you are going to have this space that can be filled by liquid. Actually, these organs, you can see like they are suspended in this space. So this space is filled by fluid, and that fluid is actually the same interstitial fluid. And it is known in the abdomen, that fluid is going to be known as the peritoneal fluid. Okay, peritoneal fluid. If you go to the brain, the fluid there is going to be known as cerebrospinal fluid. In the central nervous system, there is cerebrospinal fluid here with the spinal cord. Also for the heart is going to have different layers. The fluid that you are going to find in between the layers of the heart, that is known as pericardial fluid. So these are all types of extracellular fluid. Now let's talk about body electrolytes. What are electrolytes? Electrolytes are just ions. And in the body, we are going to have different ions. Actually, ions will make up 7% of your total body weight. Take note of that, 7%. You have got sodium ions, potassium ions, chloride, calcium, magnesium, phosphorus, bicarbonate, and these other ions. A lot of ions. Just some bit of function. Sodium is that to regulate the fluid balance, helping nerve and muscle function. You understand this, especially sodium is very important when it comes to contraction of muscles. Now, there is this table. This table is showing us the amount of fluid which is found inside the cell, and not fluid but the amount of ions found inside the cells and outside the cells. So you can see sodium ions Sodium ions are most abundant outside the cells, so they are more in ECF, and the concentration of sodium is 142 milli equivalents per liter outside the cell, while inside the cell it is about 10. And then the concentration of potassium is more inside the cell. So you need to know this table has to be like in your head. Okay. In my test one, they just brought this and they wanted us to be now filling up. These values were not there. You start filling up. Okay. So you need to know. So you need to know P's. Those things which have got a P in them are more inside the cell. Look at proteins. Proteins, you can see the concentration inside the cell is more than outside the cell. In grams per deciliter is 16. In milli equivalents per liter is 40. If you go again to potassium, it also has a P. It is more out inside the cell, 140. It's actually the major positive ion inside the cell. If you go to phosphates, they are also having a P. You can see phosphates are more inside the cell. So the P's are more inside the cell. Sodium is a major cation ion outside the cell. Now, where sodium is, that is where you find you expect to find chlorine. Think of sodium chloride. So chlorine is also supposed to be high outside the cell in comparison to inside of the cell. So if these things are not equal, it is going to be a condition. When you have got when you are measuring the amount of sodium in blood, remember blood is extracellular fluid. So if you measure the amount of sodium in blood and they say you find that the amount of sodium in blood is 130 milli equivalents per liter, that 130 in blood is less than the normal that is supposed to be in blood. So low sodium is known as a hyponatremia. And then if you find that potassium in blood is somewhere like 1, it's supposed to be somewhere 4. Low potassium is known as hypokalemia. You have also low calcium, hypocalcemia, hypomagnesemia, and then for high it is hyper. But for glucose, look at this. The normal glucose in outside the cell, in other words, the normal glucose in blood should be about 90 milligrams per deciliter. If you find it lower than that, that is going to be hypoglycemia. If it is higher, hyperglycemia. So those are some conditions that you can have and they can really ask you about them. They can bring this table, they give some different values and then they tell you what is the diagnosis, what is wrong, what condition is that, is it hyper, is that low or high. So make sure that you know this table. At least you can even be knowing the values. Maybe you know one per day. Let's say for sodium, you know what is outside and inside today. Potassium, you know tomorrow. The other one just like that. It's very important. You need to know the major ions inside the cell and outside the cell. In ICF, that is intracellular fluid, the major cations, those compounds which are positively charged, the major ones you have got potassium and magnesium. You already saw from their concentrations. And then the major anions, those which are negatively charged, you have got proteins and phosphates. Remember we said P's, right? Potassium, proteins, organic phosphates. But it's just that proteins are negative, also phosphates are negative. So that those are the major anions. But outside the cell, ECF, the major cations, those who are positively charged, the major one is sodium. And then for the anions, those which are negatively charged, you have got chlorine and bicarbonate. You also have plasma proteins, which are found outside the cells. Plasma proteins, these are proteins which are found in blood. The major ones have got albumin and globulin. These are plasma proteins. You understand them well if we talk about blood. See, this is what I'm just from talking about. You can see this is extracellular fluid, ECF, and this is the ICF. If you look at the cations in ECF, the major one is sodium, and then in ICF, the major one is potassium and magnesium. In ECF, we also have some kind of sodium, and then the ions, anions, those which are negatively charged in ECF. Because sodium is high in ECF, we expect chlorine to be high in ECF, and also bicarbonates. And then for ICF, the major one, you have got phosphates and proteins. So this is what I already talked about. When sodium is high, that is hypernatremia potassium, hyperkalemia chloride, hyperchloremia calcium, hypercalcemia magnesium, hypermagnesemia phosphate, hyperphosphatemia glucose, hyperglycemia. Now, for bicarbonates, remember we have said we also have bicarbonates. Where are the bicarbonates high? Where chlorine is high, that is where we also find bicarbonates to be high. Meaning bicarbonates are more in blood. Do you remember what we talked about in biochemistry? We said that bicarbonates are there as a buffer in blood. So we expect them to be high in blood. That is outside the cell, ECF. So when you have got now too much bicarbonate in blood, that is going to be alkalosis. If you have got low bicarbonate, that is going to be acidosis, because it means that the only way you have got low bicarbonate is meaning that you have got more acid. If pH is low, you have got alkalosis. If pH is high, acidosis. And then you also have hemoglobin levels. Okay, on this same table that I gave you, you also have hemoglobin levels, HB. Okay, on this one I didn't include, but you have got pH. Normal pH outside the cell is 7.4. In blood, this is the normal pH in blood. But inside the cell, the normal pH is neutral pH inside the cell. So meaning if the pH is going to fall below those, you are going to have alkalosis if it is high or acidosis if it's low. Now for hemoglobin, HB levels. When you see hemoglobin is just the count of red blood cells. Normally, okay, we'll talk about this. The normal count is going to be like 45%. So if it is less than that, that is going to be anemia. If you have got low hemoglobin, hemoglobin is just that part of blood that carries oxygen. You really understand this. And then if it is high, that is going to be known as polycythemia. So polycythemia is the opposite of anemia. Now let's talk about total body water. How much water do we have in a body? When you're talking about total body water, we use an average. A male, not a female, a male who is 70 kg in mass. So if they've not told you the, let's say the weight of the person, they just say what is the total body water inside. Just know they are talking about a 70 kg adult male, not a child, an adult male. So for a male, the total body water, if I am 60% of a male's body is going to be water. For a female, is different. Only 50% of your body is going to be water. That is because the 10% is occupied by fat for females. So let's say if someone is 70 kg, what will be the total body water? Total body water, TBW, is 60% of your weight. Let's say we are talking about someone who is 70 kg. So 60% of 70 kg, that is 60 out of 100 times 70 kg, that is going to be 42 kg. Now you know that the density of water is 1 kg per liter, so you can multiply by 1 kg per liter, which is the same as in 1 liter of water, you have got 1 kg, okay, or 1 kg per liter, or 1 liter per kg. That's the density of water. So the kg can cancel the kg, so the answer becomes 42 liters. So meaning that the body of an adult male, a male who is 70 kg, is going to be 42 liters. So let's say you are having a mass of 50 kg. What will be your your total body water. How much water are you going to have in the body? That will be 50, that will be 60% times that's your weight, right? So total body water is 60% of the total body weight. For a female, it's 50% of the total body weight. But children have got more water. Actually, 75% of their body weight is going to be water. So if you want to find the total body water for children, use 75%. So this is what you can see. You can see this is representing uh, here the child is still in the mother's womb, and then the child has started growing, going to this direction. You can see the total body water in the body when the child is around 4 months inside the womb. About 90% of the entire body is water, but as the child grows, you can see total body water is falling. And by the time the child reaches puberty, and then there'll be a difference between a male and a female, how much water they are going to have. For a male, it is 60, for a female, it is going to 50 there. Okay. So the total body water we have said is 60% of the body weight. And then of the remaining percent, which is 40%, you are going to have 18% being proteins and other substances, 7% being the minerals, the same ions that we talked about, and then 15% of your weight most is going to be fat. Now, since we have said the body is going to have 60% water in a normal adult male, how is that water going to be distributed? Inside the cell and outside the cell, and also in those compartments that we talked about. So remember we talked about ICF and ECF. So total body water, we have said that it is 60% of the weight. Now, of that water that is in the body, okay, of that water that is in the body, what will be inside the cell, that is ICF, will just be 2/3. And what is 2/3? 2 out of 3 times 100, if you want to calculate that as a percentage, is about 67%. So meaning that 67% of the water that is in the body is going to be inside the cell. Majority of water is inside the cell. So ICF is 2/3 of total body water. But remember, total body water, we said total body water is 60% of the weight. So 2/3 times 60% of the weight, that is going to give you 40% of the weight, meaning that the water that is inside your cell is 40% of your weight. And if you want to find the exact value, we are going to show that. And then the water that is outside the cell, if you want, you can just say, you know that total body water is 60% of the weight. And then what is inside the cell is 40% of the weight. So what will be outside will be 60 minus 40, that is 20. Or you can say the water that is outside the cell is 1 out of 3. Okay, or 33, that is like 33.3% of the total body weight water. And total body water is 60% of the weight. So that gives you 20% of the weight. You need to know this, and this is very easy. I've tried by all means to make it that easy because it can come in a multiple choice like that. So now, since we have said that ICF is 2 over 3 of total body water, we can also say 2 over 3. We know that total body water is 43 liters, right? So meaning that the water that is outside the cell is 20, inside the cell is that around 28 liters for a normal 70 kg adult male. And then the water that is outside the cell is around 14 liters. Now remember, this is ECF. What makes up ECF? We said that you have got interstitial fluid, which we also call as interstitium. Apart from that, we have also plasma, that liquid that is in blood. Okay, and we said we are also having transcellular fluid, but we said that transcellular fluid is actually part of the interstitium and lymph. So meaning that of these 14 liters, some of it is going to be found in blood, and then some of it will just be found between cells. Now what percentage will be that? So the liquid that is found in blood is going to be 1 over 4, or 25% of the liquid found outside the cell. And the liquid found outside the cell, which is ECF, remember we said it is 1 out of 3 of total body water. Okay, we said it's 1/3 of total body water. And remember we said that total body water is 60% of the weight. So if we multiply these two values, it will give us 1/12 of total body weight. And total body, not total body weight, but total body water. Total body water, we said, is 60% of the weight. So you find that the liquid found in blood is 5% of the weight. 5% of the weight. That is how much water you are going to find in the blood vessels. And then the interstitial fluid just between cells, it is going to be 3/4. That is 75% of all the fluid that is outside the cell. So that will be 3 out of 4 of ECF. And remember, ECF is 1 out of 3 of total body water. And total body water is 60% of the weight. So that is going to give us 15% of the weight. If you add 5% and 15%, it will give you the total, which is 20% of the what? 20% of ECF. So we can actually calculate the how much blood we expect, how much fluid we expect to be inside blood vessels. 5% of the weight, and we are saying that the weight here is 70 kg. So 5%, so that is 0.5 out of 100 times 70 kg. So inside the blood, you expect to find 3.5 liters. Okay, and this is the one. So plasma, the liquid found in blood is plasma. So plasma is going to be 1/4 of ECF, and ECF we know that is 14 liters. So that will be 1/4 times 14, which is 3.5. And then interstitial fluid is going to be 3 out of 4 of ECF, and ECF is ECF is 14 liters, so that gives us 10.5 liters. If you add these two, they'll give you the 14 liters, which is the ECF. Now, this is plasma. What is plasma? Plasma is just the liquid part of blood. Now, if you get a blood vessel, in a blood vessel, you are going to find blood. What makes up blood? You are going to have blood cells and water. So if you are trying to find the total blood volume is 8% of the weight. But remember, we have just said that plasma, just the liquid part of blood, is what? 5% of the weight. How about the extra 3%? So the extra 3% is what makes up now other things which are found in blood, including the cells found in blood. Meaning that the cells found in blood, they're actually 3% of your weight. So you can calculate also the total blood volume by saying plasma volume divided by 1 minus hematocrit. Total blood volume, how much blood do you have? Not the liquid part of blood, but the liquid part including cells. How much do you find? So that is going to be given by plasma, just a liquid part of blood, divided by 1 minus hematocrit. Hematocrit is just giving is just a number of cells, red blood cells in blood. So if I say 1 minus red blood cells, then I'm talking about just that part of blood that does not have the red blood cells. 1 minus the part that has got red blood cells, that is hematocrit. And hematocrit is mostly 45% or 0.45. So you can actually calculate the total blood volume by saying plasma volume, as we've already calculated, plasma volume there, you can say 3.5 divided by 1. We are saying hematocrit is 45%, which is the same as 0.45. Let's see what it's going to give us. I'll start by saying 1 minus 0.45, that is 0.55, and then we say 3.5 divided by that answer. That is going to give us around a 6.36 if we use this calculation. This is going to be in liters, meaning that this is the total blood volume. Okay. Do you have any questions? Any questions? Okay. So this is a simple table to just summarize what you have said. You have said total body water is 60% of the weight. This total body water is going to be distributed inside the cell ICF and outside the cell ECF. What is inside the cell is going to be 40% of the weight, or 2/3 of the total body water. What is outside the cell is going to be 20% of the weight, or 1/3 of total body water. If we add 20% and 40%, it should give us 60%. And then on the ECF, we can have that which is found in interstitium or interstitial fluid or in blood as plasma. We have said plasma is 5% of the body weight, or one quarter of ECF. And then the interstitial fluid is 15% of the weight, or 3/4 of ECF. If we add 15% and 5%, it should still give us a 20. So this is a summary of that. We also have what we call lean body mass. Now, lean body mass is the fat-free mass. The mass in your body, you have got the mass that has got water, the mass that has got fat. Now you're talking lean body mass is your mass which does not have any fat. Okay. So when you want to calculate the total body mass, how much mass do I have? It will be a sum of the part of my body that has got fat and the part of my body that is free from fat. If I add them, it will give me the total body mass. But now you know that fat does not combine with water, meaning that it is anhydrous. Okay, fat is hydrophobic, meaning that where you expect to find fat, you don't expect to find the water, but you are going to find just a bit, like, okay. So the water content of lean body mass is going to be the same. In other words, the water content of that part of the body that has got no fat is the same. Let's say this is a tissue. This is a tissue. It has got no fat. The water content will be the same. So if I get, let's say this is 100 grams of a tissue from the body, it has no fat. If it does not have any fat, it means that of every 100 grams of tissue that I get, 70 mils, it is going to have 70 mils of water. Of every 100 mils of tissue that I get, you are going to have 70 mils of water. Every 100 mils, 70 mils of water. Let's say I get 2 kg of tissue. How much water is going to be in this one? If, let's say, it does not have any fat in it. So we're going to just multiply, okay, by 70 mils in each 100 grams. But I need to convert this 100 grams to kg. So this is like a 0.1 kg. So that will give us how much water is in 2 kg of a tissue that does not have any fat. That is what we call lean body mass. Let's do a simple calculation. For a healthy adult male, and this male is 70 kg, what is the lean body mass? What is his fat mass? First thing we should calculate is total body water. You know that total body water is 60% of the weight. And so we're going to say 60% of 70 kg. 60 times 70, that is what? 100. I mean 60%, 60 over 100 times 70. That is going to give us 42 liters. If we assume all the water is in lean body mass, in other words, all the water is in that part of the body that does not have any fat, and you know that lean body mass, for every 100 grams of tissue, you have got 70 mils of water. Every 100 grams of tissue, have got 70 mils of water. But now look, we have got 42 liters. So how many grams of tissue are we expecting? So just multiply 100 grams of tissue over 70 mils of water times this 42 liters. But because this is in mils, convert that liters to mils. Just multiply by 1,000. So that will give us that lean body mass is actually 60 kg. What is lean body mass? This is the part of the body that does not have any fat. So how much part of the body is going to have fat? So fatty mass is going to be total body mass minus the lean body mass. So the total mass, remove that part of the body that does not have any fat. It will give you that part of the body that has got fat. And then the total body weight for this person is 70 kg. The part that does not have any fat is 60 kg. So meaning that the part that has got fat is just going to be 10 kg. That is how you can calculate lean body mass and fat mass. Hope that makes sense. So you need to know at least some special places where you find transcellular fluid. We said, remember, transcellular fluid is fluid found in special cavities in the body. You have got the pericardial fluid, the fluid found on the spaces in the heart. That is around 50 mils. It's very small. It has got just a little fluid. Pleural fluid, this is the fluid found in the lungs. That is about 10 to 20 mils. Peritoneal fluid. So peritoneal fluid is the fluid that is found like in the peritoneum. Peritoneum is just where you find these organs, like these reproductive organs. Males don't have any fluid. For females, it's just around 20 mils in the peritoneum. That is when you're talking about early luteal phase. Now you understand about luteal phase and late luteal phase and those things. Synovial fluid, the fluid found on your joints, like your elbow and your knee. That is just around 1 mil, very small fluid. Okay. A 30-year-old pregnant woman in her 37 weeks of gestation is found to be carrying a macrosomic baby who is 5 kg in weight. Before she became pregnant, this woman was weighing 90 kg and only gained weight due to the pregnancy. She is now 95 kg because her baby is 5 kg. Macrosomic means that the baby is very fat, very big. So the first question is, name the different body fluid compartments, the size of each, and ways in which they can be measured. And this question is very much common. I've seen it in a lot of exam questions. So the first question is, name the different body fluids, the size of each, and ways in which they can be measured. And then compute the amount of water found in the intravascular space. Find the ECF and ICF of this baby. Compute the tissue fluid of this pregnant woman. So the first question saying, name the different body fluid compartments. We have got ICF and ECF. ECF, we have got intravascular fluid, which is just plasma fluid, the fluid inside the blood vessels. That's why we're saying intravascular. Also have interstitial fluid and then transcellular. Transcellular is mostly negligible. You can see here I've just said 1%. And then the second part was saying the size of each. ICF is 40% of the total body weight. ECF is 20% of the total body weight. Of the ECF, plasma is 5% of the total body weight. Interstitium is 15% of the total body weight. Transcellular is less than 1% of the total body weight. That's why we take it negligible. And ways in which they can be measured. Now, how can you measure these compartments? We'll talk about that. For B, saying compute the amount of water found in the plasma space or the intravascular space of this pregnant woman. Intravascular meaning that in the blood vessels, how much water are you going to find there? And also find the ECF and ICF of this baby. So if you see intravascular space, the fluid found in a blood vessel is 8%. Okay, the fluid found in the blood vessel is 8%. This is not really plasma, just the liquid part of blood. You're talking about everything found in a blood vessel. That is 8% of the total body weight. So you can see the total body weight of this woman is 95 because she's pregnant. She's 90, but the child is 5. So you add the mass. 95 times 0.08, that is going to be 7.6. Now the ICF of the baby, you know that ICF is 40% of the weight. So that is going to be 40%. The baby is 5 kg, that is going to be 2 liters. And then ECF of the body of the baby, ECF is 20% of the weight. That is 0.2, which is 20% times 5 kg, which is 1 liter. Interstitial fluid, that is the compute the tissue fluid of this pregnant woman. That is interstitial fluid. That is the fluid found in between the tissue. Explain the reason as to why the transcellular fluid is less than 1%. So the interstitial fluid is the weight times the interstitial fluid percentage. Now remember, interstitial fluid is 15% of the weight. That will be 15% times 95, and that will give you 14.2. Why is transcellular fluid less than 1%? This is because transcellular fluid is confined to only small places in the body. Okay, that's why it's less than 1%. Now, how do you measure fluids of the body compartments? How are you going to measure that this fluid is inside the cell? This is how much fluid is inside the cell. This is how much fluid is outside the cell. You can use what we call the Steward Hamilton dye dilution method, also known as indicator or just dye dilution method. Now, I remember this question coming in my exam. You want you want to get a dye. That dye, you inject it in the person so that wherever that dye is going to go, it will mark every point where there is water, and so you can measure how much water is in the body. Okay, so the fluid or the dye that you choose should meet some characteristics for you to use it. It must mix evenly in the body, meaning that if you want to measure ECF, it should go at every point in the body where ECF is. It must not be toxic. Okay, meaning it shouldn't hurt you if you inject it in the body, and it should mix evenly. It shouldn't be more on one part of the body and less on the other part of the body. Must have no effect of on its own on the distribution of water. If you inject it in the body, it shouldn't take water to one side, or it shouldn't cause water to be lost from the body or such. Okay, and it should also be unchanged during the experiment. If I injected 20 mils, it should be the same 20 mils when I come to measure the concentration. If there was any change, I need to measure how much was excreted or how much was removed. And then the material should be relatively easy to measure. I don't want to use something that is called that is difficult. So if you want some dyes that you can use, if you want to measure total body water, you can use D2O. Why do we use D2O? D2O is just heavy water. We can also say triated water. We use D2O this because D2O will go at any point in the body where water is, whether inside the cell or outside the cell. That is why you can use it to calculate total body water. And then to calculate ECF. Remember, ECF is just a fluid outside the cells. We can use mannitol and sucrose and also inulin. Now, the reason as to why we even use mannitol, sucrose, or inulin is because these guys, they cannot pass the cell membrane of a cell to enter the cell. So they only be outside the cell. So if we measure the concentration of these guys, we are actually determining how much we have fluid outside the cell. If we want to measure the fluid that is inside the blood, we can use Evans blue. That is because Evans blue cannot move out of the blood. If you inject it in blood, it will just remain in blood. It can't go anywhere else. So it can be well used to measure the fluid inside the blood. Okay. So now how do you calculate how much fluid you have, or the volume now of a body compartment? So using the dye dilution method, what you do is imagine I injected mannitol. Every time they tell you that they've injected mannitol, you need to know what they are measuring. Mannitol means that we are measuring what? We are measuring ECF. So if we inject, let's say, 20 grams of mannitol, and then this person goes to the toilet, they excrete, let's say, 5 grams of mannitol, and the concentration of this mannitol, let's say, was 15, okay, let me say, was 10 grams per mil. They say find the volume of the compartment that is being measured. In this case, it is ECF. They will not even tell you. And another question that can follow is they'll ask you what compartment is being measured. So to find out the volume will be the amount which was injected. In this case, is 20 grams. Remove the amount which was excreted. If there was no excretion, then don't remove anything. So 5% is excreted or metabolized. Divide by its concentration, that is 10. So in this case, it will be 15 out of 10, and that will be like, is it a 0.15? Okay. In this is going to be in mils, looking at the unit that I used. So this would be the amount in that case of ECF if that was what we were given. So you can measure directly total body water using a dye. ECF, there is also a dye that you can use. You can also measure plasma using a dye. We've already talked about the dyes. Also plasma volume, also blood volume. Now ICF, I've not talked about any dye that can go just inside the cell. So meaning that it is indirectly measured. The only way you can measure ICF is first, you need to know the total body water, and then you remove ECF. That is how you can measure ICF, meaning that it is measured indirectly. And the only way you can measure interstitium is also indirect. How do we measure interstitium? Interstitium is given by ECF. If I know ECF, I just remove plasma fluid, then I remain with interstitial fluid because plasma and interstitium will give us ICF. Okay, so that is how you use this method. These are some other dyes that you can use. You can see for plasma volume, apart from Evans blue, you can also use the iodinated albumin. They can bring this in multiple choice. Why do you use it? Because it can't cross capillaries. ECF, you can use inulin. It's actually the best that can come. Inulin, mannitol, sucrose. You can also use, you can see the sodium and these others. Why can we use this? Because these cannot cross the plasma membrane to go inside the cells. Interstitial fluid, there is no direct method, so you just say ECF minus plasma. Total body water, you can use it antipyrine, heavy water, which is D2O, or triated water. Why can you use these? Because these can cross capillaries and they can also cross the cell membranes, and so can measure at any point where there is water. And then interstitium, there's nothing that you can use direct to measure. For blood volume, if you want to find out how much blood you have, it's different from plasma volume. For blood volume, you can use chromium labeled red blood cells, or you can use this formula. We already talked about it. Blood volume is plasma volume over 1 minus hematocrit. Okay, so that is it. We can end here, and this other part we'll do. Now, what I want you to do is, you should be able to try out these are questions from the exam. I want you to try them out. Volume of ICF in the body dash. ECF is how much of total body water. Calculate the percentage distribution of fluid. And this one came in just the other year's exam. Okay. Also this one also came the exam before last year. Also this one, you can see what they brought. They brought these values for that table, and then they asked, with your knowledge on cellular fluids, explain these results. They have given you sodium is 97. What is wrong? What is wrong with 97? Potassium is 10. What is wrong? And this question, look, was 10 marks. Okay, so explain what is wrong. All right, so let's end here. We'll continue now in the next class.